Okay, so here, what is the rule on this? We have z to the 7th over z to the 12th. And we want to figure out how to simplify this expression. What do we do? Well, basically, let me show you an example over here. What if we had x to the 5th over x squared? You know what that means, right? It's 5x's over 2x's, and then we can cancel. And so what becomes of it is x to the 3rd. And so the rule is you should subtract to get the answer, right? I'm just showing it longhand. 5x's over 2x's, cancel, 3x's. So you should subtract. 5 minus 2 is 3, and that gives you the answer. But what if the bigger one's on the bottom? What if you have x squared over x to the 5th like that? Well, let's just try it again and let's see what the rule is. So we have 5x's this time on the bottom, 2x's on the top. Okay, and we cancel. So what are we left with? Well, we're left with x cubed on the bottom. Now, can I just say x cubed? No, I gotta put it like that, 1 over it. When you have nothing left on the top, you have to put a 1 over it, right? If you just write x cubed, that's not correct. That's okay up here because all we have is x cubed on the top. Now you might say, well, Mr. Aaron, why didn't you put a over 1 here? Because we had nothing on the bottom. Shouldn't that be 1 there? Wouldn't that be x cubed? Like this is 1 here and this is x cubed. Well, yeah, okay, true. But then that's just regular x cubed. Remember, having 1 on the bottom, we can ignore. Having 1 on the top, we cannot ignore. It must stay that way. Now, let me help with that. I don't want that just to be some rule Mr. Heron says. I wanted to show you that that's simply what's true. If I say 3 divided by 1, right? You know what, here, let's go over 10 divided by 2. What's 10 candy bars divided among 2 kids? It's 5, right? Because 2 goes into 10 5 times. 1 goes into 3 times, right? The bottom into the top. That's why anything over 1 is just the same as itself. You see that? But you think, okay, well, then do that with 1/3. That is not the same as 3, right? You can't just say, I'm just going to ignore that. Well, I had 1/3 of a candy bar, but that's the same as 3 candy bars. No, it's not. Those are very different. You can't do that, right? When you have a 1 on the top, that must stay. But when you have a 1 on the bottom, well, that just means 1 into 3 is 3, right? Or 3 candy bars for 1 kid is 3 candy bars per kid, right? The ones on the bottom vanish because they should, because that's what they mean. Whereas ones on the top must stay. So let me write that. Ones on the top must stay on the top. But ones on the bottom vanish, don't they? Because that's true, right? If you have a 1 on the bottom, 1 goes into 3 times. Or 3 candy bars for 1 kid is 3 candy bars per kid, right? Whereas if you have 1/3, that's not the same as 3. We can't just cancel that 1 and say, oh, that's the same as 3. It's not. Okay, so long story short, what does that mean? So it's a lot of talk for me to say, look, wherever the higher power is, that's where the answer ends up. So if the higher power is on the top, 5 minus 2 is 3, and the answer is in the top, meaning it's just regular. You don't have to put it over 1. 1's in the bottom, vanish. Whereas if the higher power is in the bottom, then the answer ends up on the bottom with a 1 over it, right? So let's do that here. Let's do exactly that. So I'm going to come in and go 12 minus 7. That's going to be 5. And that goes on the bottom because the bigger power is on the bottom. So wherever the bigger power is, that's where the answer is. If the bigger power is on the top, the answer is on the top, meaning over 1. The answer is on the bottom, bigger answer, the answer is on the bottom. So there we go. So you always have the answer wherever the bigger power was.